So today we're doing more two-variable inequalities. So I think we've done some absolute value graphing, like we've done y equals absolute value of x plus 2 minus 3. And we've also done some graphing like y is less than 2x plus 1, or some linear graphs. Today we're combining those two things. So here we've got an equation right here where we have an inequality that's also an absolute value. So the first think, okay, dotted or solid. So we see this sign here. There's no equal sign, so I'm going to draw a dotted line. And I'm basically graphing this equation without an inequality. So I'm going to start with my 5 points that I know and love. This is the 5 points from the parent graph for y equals absolute value of x. And then I'm going to, let's see, this is going to move it, 2 units to the left and 3 units down. So every point is going to move 2 units left and 3 units down. 2 units left and 1, 2, 3. That's the vertex. 2 units left, 1, 2, 3. 2 units left, 1, 2, 3. And these 2 points also move. And so I've got I'm going to graph that with a dotted line. And now look at the sign, and so the sign, let's see, this is going to be less than. So I'm going to shade below this graph is what I think. So let's go ahead and shade below the graph. So below the V, kind of not inside of the V there. So all of that is shaded. And if you're not sure about one of those points, we can always, like we did the other day, we can test a point. So let's test like this point is clearly inside the shaded region. So that's the point 2, 1. Or sorry, 2, negative 1. So let's plug that in here. That would be negative 1 is less than 2 plus 2, the absolute value, minus 3. So that's 4 minus 3 is 1. Is negative 1 less than 1? Well, I think that's true. So it's true, so that should be the shaded region, and it is. So it's not that much different than what we've done in the past. Let's try another one. So what's tough about some of these things is we always want the leading coefficient to be 1. I think I'm going to try this one first, and then we'll come back to that other one. So right now, the leading coefficient in front of x here is kind of like a negative 1. And I don't want that. I want that to be a positive 1. So we're going to try to rework this just a little bit to get that coefficient to be different. So y greater than or equal to absolute value. So inside of this absolute value, I'm going to kind of factor out, if this makes sense. So I'm going to factor out a negative 1. So I'm taking negative 1 out of this expression. So this is going to be negative 3 plus x. I'm going to write it differently here because I don't like writing the negative 3 first. So I'm going to rewrite y is greater than or equal to the absolute value of negative 1 times, I'm going to write it as x minus 3 absolute value. So now the coefficient in front of x right here is actually 1. I took the negative 1, I factored it out as a GCF. I took out a negative 1 from this function. So now I can look at this just like kind of a normal graph here. So if you saw this, you would go, well, which direction is that one moving? You're taking the 5 points that you know and love, right here, 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 for the parent graph, and all the points are going to move to the right 3 units. So every point moves 3 units to the right. This goes 3 to the right. This goes 3 to the right. This one is 3 to the right, and this one is 3 to the right. So pretty soon on my graph, this is going to be a solid line because of the inequality sign. It's equal to there. And it says it's greater than or bigger than. So I'm going to shade kind of on the inside of this piece. So inside of the absolute value V there. So all in there, if you want to test a point, you can test a point and make sure that the point 3, 3 is in the shaded region. So if you plugged in 3 is bigger than or equal to 3 minus 3, that would be 3 is bigger than 0. That's true, so that is part of the shaded region. So this one's kind of tough because it's got a 2 in front of there. I always want a leading coefficient of 1 inside of there. So I'm going to factor the 2 out. This is not really a GCF so much as it is I just need that coefficient to be 1. So I'm going to factor out, so it's going to be y less than absolute value of. I'm going to take the 2 out, and so inside of those parentheses, inside the absolute value, I'm going to take a 2 out, so it's going to be x. When I take a 2 out, I'm essentially dividing a 2 out, so this is going to be plus 3 over 2. And so now the coefficient in front of x is technically 1. I know there's a coefficient out there, but we're just kind of ignoring that. We could even, if you wanted to, this would make you feel better, you could put it out here. So you're allowed to take out a number like a positive number like that. So you could say 2 times the absolute value of x plus 3 halves minus 2. So we've got a slope there basically that's be stretched by a factor of 2, but this is going to move it in the direction of to the left, 1.5 units. So it takes the 5 points. We know well, it does a couple things. Let's first we can multiply those points by 2. So if you do that with the ordered pairs, you're going to have these 5 points. So that's like your skinny graph, right? Right now, it looks kind of like those 5 points. This point, this point, this point, and this point. That's just from multiplying the y values of those points by 2. They're going to move, every y value is going to move 1.5 units left, that's 3 halves, and 2 units down. So I'm going to go 2 units down, 1.5 to the left and 2 units down, right about to there. 1.5 to the left and 2 units down. 1.5 and 2 units down. 1.5. Excuse me, sorry about that. So you've got your kind of graph here. It's going to be a dotted line. Sorry, it's going over my numbers there. And it says it's less than, right? So because this sign is less than, I'm looking to shade below this graph, which if you look at the blue graph is going to be, all this is shaded right up until about there. Everything below the V is shaded. You can test a point to be sure that you got it right. Let's look at a couple more. So again, these are kind of tough with this leading coefficient here. So I'm going to pull out this negative because I want that to be 1. So y plus 1 greater than absolute value of, I'm going to say negative 1 times x plus 2. So I factored out a negative 1 from both of those. And really, it's probably a good idea to go ahead and add 1 to both sides, or subtract 1 from both sides here. So get that 1 on the other side. So I'm going to subtract 1. So this is doing a couple of things here. So it's going to move to the left 2 units and down 1 unit here. Essentially, it's negative. If you think about it, it doesn't really do anything, because if that whole quantity is negative, but then I have the absolute value bars around it, it'll become positive. So that negative is actually inconsequential. It doesn't really do anything in this equation. So I'm going to start with my 5 points that I know and love, my parent graph points. I'm going to move every point, let's see, 2 units left and 1 unit down, 2 left and 1 down, 2 left, 1 down, 2 left, 1 down, 2 left, 1 down, and 2 left, 1 down. This is going to be a dotted line. You got kind of a V there. Sorry, this is kind of messy on this computer here. And greater than is going to shade above, right? So it's going to shade up above. So everything in here is going to be shaded. Let's try a change of pace. So if you're given, in this case, we have the graph, you have to write the equation. So this is just kind of working backwards here. So let's start with y. The shading is down, and it has a dotted line. So I think that's going to be less than without being equal to. The vertex seems to be at -1, -2. And the slope of this line goes up 1 over 1, up 1 over 1, and it's positive. So I think it's just absolute value of x plus 1. That's going to move it 1 to the right, or 1 to the left, actually. And then -2 means down 2, so -2. And that's your equation for that inequality. Let's try one more. Last one. So first of all, start with the function here. So this would be y is greater than or equal to. There's a solid line, it's shaded above, so it's greater than or equal to. The slope looks to be, let's see, it goes up 1, it goes over 2 in the negative direction. So, and it is negative here. Notice the slope is sloping down, so it's definitely negative. So it will be negative 1/2. I should say negative absolute value of. Well, let me put it out front. I think it'd be easier to write it out there. Let's see. Okay, so negative 1/2 times the absolute value of x. Let's see, this point is at 1, 2, 3, 4, negative 4, comma 3. So this is going to be absolute value of x plus 4 plus 3. And you've got your graph here. So that's enough for the screencast. Go ahead and start on your homework. If you have questions tomorrow, we'll go over it in class.